All right, let's dive into something that's literally changing our world, machine learning. We're going to talk about how computers are learning to think, not because we're giving them every single instruction, but because we're letting them learn from experience, kind of like we do. It's fascinating stuff. I mean, seriously, have you ever stopped to think about your email? How does it know what's junk and what's important? It's not like some programmer is sitting there writing a new rule for every single spam email that gets sent out, right? That would be absolutely impossible. So, what's the secret?
Well, that's where machine learning comes in. This is the big idea. We build systems that can find patterns all by themselves. So instead of us telling the computer, hey, if an email has this word, it's spam, we just show it thousands of examples, some spam, some not, and we let it figure out the patterns on its own.
Okay, so here's our roadmap. We're going to look at the main ways computers learn, with a teacher, all by themselves, and even through trial and error. And then, and this is super important, we'll see how we check their work to see if they actually learned anything. First up is the one you'll see the most, supervised learning. And honestly, the best way to think about this is just like a student learning with a teacher. The teacher has all the study guides and, most importantly, all the answer keys. So the teacher, in this case, gives the computer a huge set of data where every single piece of information already has the correct answer attached. It's just like studying with flashcards. You've got the question on one side and the right answer on the back. Let's make this real. Say you want to build a system to spot fake money. You'd show it thousands of pictures of banknotes, and each one would be carefully labeled authentic or counterfeit. After seeing enough examples, the AI model starts to get it. It learns the subtle patterns so well that when you show it a brand new banknote, one it's never seen before, it can make a really, really good guess. Now, this whole learning with a teacher thing is perfect for two main jobs. The first is classification, which is all about sorting things. Is this banknote real or fake? Is this email spam or not? The second is called regression, and that's when you're trying to predict an actual number, like what's a house going to be worth next year? But what happens if you don't have a teacher? What if you've just got this giant mountain of data, but no labels, no answers? Well, that's where things get interesting. This is unsupervised learning, where the AI is basically on its own. Yeah, in this case, we pretty much just drop a whole bunch of data on the computer and say, go find something interesting. There are no right answers to study from. The machine's job is to just sift through everything and see what hidden structures it can find by itself. And the main tool for this is something called clustering. The algorithm just looks at everything and starts putting similar things together. It's basically creating its own categories from scratch with zero human help. And this is huge in the real world. Think about market research. A company can take all its customer data, feed it into a clustering algorithm, and have it automatically group people into different segments. You know, the bargain hunters, the loyal regulars, the ones who just browse. It's incredibly powerful for understanding behavior. Okay, our third style of learning is way more active. It's called reinforcement learning, and it's all about learning by doing. Forget flashcards. This is more like learning to ride a bike. You're going to fall, you're going to get it right, and you learn from the feedback. So here's the setup. You've got an agent, which is our AI, and you put it in an environment, let's say a video game. The agent gets to take actions, and every time it does something, the environment gives it feedback, a reward for a good move or a punishment for a bad one. And it just learns in this constant, relentless loop. It tries something, gets a score, tweaks its strategy to try and get more points, and then does it again and again, millions, sometimes billions of times. When you hear about an AI beating a grandmaster at chess, this is how it happened. But this whole process creates a really interesting problem, the balance between exploration and exploitation. Think about it. Does the AI just exploit what it already knows works to get easy points? Or does it explore by trying a crazy new move that might fail, but could also lead to a massive reward? Getting that trade-off right is the secret to creating a truly smart agent. So we've got these incredible ways for machines to learn. But after all that work, all that training, we have to ask the biggest question of all. How do we actually know if it's any good? How can we tell if it's really learned anything? Because here's the danger. A model could just get an A+ by memorizing every single question and answer in the study guide. But the second you give it a new problem it's never seen, it completely falls apart. That's not learning. That's just cramming for the test. And there's a name for this. It's called overfitting. This is when the model gets so obsessed with the tiny little details and all the random noise in the training data that it completely misses the big picture. It aces the practice test, but it totally bombs the final exam.
You can see it so clearly here. Look at the left. That overfit model is just a chaotic, squiggly mess trying to hit every single point. But the model on the right, it's smooth. It ignores the noise and captures the simple underlying trend. That's what we want. That's real learning. And the solution to this whole problem? Well, it's actually beautiful in its simplicity. You do the same thing a good teacher does. You don't give the student the final exam to study from. You hold some of the material back for the test. So a really common way to do this is an 80-20 split. The model gets to see and learn from 80% of the data, that's its study material. The other 20%, that gets locked away in a vault, that's the final exam. The model never ever gets to see it while it's training. So the process is simple. You train your model only on that big training set. Then, once it's ready, you test its performance on the hidden testing set. And that score, its performance on data it's never seen before, that's the true measure of how smart it is. Let's go back to our fake money detector. This is exactly how we'd pick the winner. We could build a few different models, each trying a different strategy. We train all of them on the same study material, but then we grade them on the same final exam, the hidden test data. And the one with the best score? Here, that's clearly Model 3. That's our champion. So there you have it, from learning with a teacher to figuring it out alone to pure trial and error. These are the foundations of how machines learn, and it powers so much of what we see every day, which kind of leaves us with one final big question to chew on. If computers can now truly learn from experience, where does their learning end, and where does ours even begin?